Okay, so for this lesson, graphing linear functions, when you hear the word function, just think of a linear equation, but they changed the label. So you see in the linear equation, we have y equals mx plus b, right? All they're doing is changing this front label, y. Instead of it being y equals mx plus b, it's going to say the function of x equals mx plus b. But you pretty much treat it exactly the same as you do when you're dealing with graphing linear equations. The difference will come later when you're graphing the function of a function. But we don't do that right now. You get to that in Algebra 2. So don't let the f of x scare you. All that's saying is function of x, which means x is over here in the equation. Okay? All right, so let's look at example 1. We're going to find the value when the function of x equals 3x minus 15, and they tell us that x equals negative 3. So basically, you're going to plug in that negative 3 where you see the x. So the function of negative 3, and you're not solving this, this is just a label, equals, you're going to solve the right side. 3 times negative 3 minus 15. So what is 3 times negative 3? Negative 9 minus 15. So negative 9 goes further negative. It'd be what? Negative. Add those together, you get. So the function of negative 3 for this particular equation equals negative 24. Okay? Any questions on that?
No.
Okay. So let's do another one. This is example 2. We have the function of x equals, not negative, 2x minus 10, and find the value of x so that the function of x equals 6. Okay, now this one's set up a little different. You see how they want the function of x to equal 6, whereas in the last one they said x equals the negative 3. So they want this answer on this side to be 6. So you're going to plug in 6 equals 2x minus 10 and solve for x. You see the difference? So then I'm just going to add 10. So I get 16 equals 2x. Then I divide by 2. So what does my x equal? 8. So you can say that when x equals 8, the function of x equals 6.
Wait, so when
Because we solved so that x equals 8, and because we knew the function of x equals 6.
do we have to write that sentence from there?
Let me check. I don't think so. You just need to pay attention to whether you're solving for the function or for the value of x. I think almost all of these you're finding the first section I assigned you, you're finding the function when they give you x, so you plug x in. And then the second one, the second section I gave you was they give you a function and you're solving for x. So you're just doing each, but you don't have to actually label it like that. Okay. Do you guys remember what domain and range are?
Yes.
When you're looking at a graph, a table, domain is which one?
The X.
And range is the y. Okay, same thing when you're graphing a function. Okay, the difference is instead of this saying y right here, it'll be f of x. But again, you treat it like the y when you do the graphing. So let's look at example 3. The gray wolf population in central Idaho was monitored over several years of a project aimed at boosting the number of wolves. The number of wolves can be modeled by the function f of x equals 37x plus 7, where x is the number of years since 1995. Graph the function and identify its domain and range. So when you do a domain and range, you just take your equation and you plug in some points for x. Doesn't matter. I always just pick 0, 1, 2, or sometimes I'll do -1, 0, negative, or +1. And then you're plugging those in for the x value over here and solving for the function. So if I plug in 0 there, I get 7 as my answer here. If I plug in 1 there, I get, what's 37 plus 7? 44? Right? If I plug in 2, 37 times 2 plus 7 would be 81, right?
Oh, is that a 44?
Yep, it's squished. I'm sorry. I can erase it and make it look better.
Yeah, you.
Cool. All right, and so then the last thing, it says identify the domain and range of the function. So the domain is all of the x values, right? But you notice that it's when you're graphing it, it's going to keep going because this is a graph about wolves, right? So the domain would be anything greater than 0 because you can't have years less than 1995 because they didn't start tracking them since before then. The study started in 1995. Whereas the range is, so what's the smallest number in the range? So it'd be f of x, everything greater than or equal to 7. So it's any numbers greater than or equal to, because this is a exponential, well, it's not exponential, but it is going to grow at a constant rate. And then the last thing they have you do is graph it. So my graph is probably need to do these lines by 5s to get to 44 at least, right? So my first dot's going to be somewhere in there. We're just going to say it goes up by this. You'll have a better graph than I will when you graph it. I just graphed this equation right here. Any questions? All right, let's look at the key concept. Make sure you've written this definition in. All right, parent function for linear functions. The most basic, let's talk about family of functions first. A family of functions is a group of functions with similar characteristics. For example, functions that have the form f of x equals mx plus b. So if all of the functions have this form, then they're called the family of functions. When you have the most basic linear function, see how it draws a straight line right through the origin? That's called the parent linear function, and that can be represented by f of x equals x. That's where it's going to go through the origin, and you see the rise over run is 1. Okay? So, let's graph and compare some of these. Let's look at example 4. We're going to graph g of x equals x plus 3. G of x is the same thing as f of x. They just used a different variable. So let's graph this. Let me grab a graph. So what's my y-intercept? 3. So I'm going to go up to 3 and put a dot. What's my slope?
1.
Up 1 over 1. And graph it. That's it. We're going to compare it to this next one. So b is h of x equals 2x. Oh, we're comparing, I'm sorry, I read the instructions wrong. Graph the function, compare that graph with the graph of. So we're comparing this with f of x equals x. So we're comparing it with the parent function. So to graph on this first graph, my y-intercept is what? It's at the origin, right? This one up here. And then my slope is, again, 1 over.
Which one? Oh, 1.
Up here, yeah. So
That,
we're doing a still because we're comparing it with the parent function. Okay, so if you look at these, what do you notice?
Parallel.
They're parallel. Absolutely, they have the exact same slope, and they start at different y-intercepts. All right, so now let's look at B. We're going to graph 2 more. So let's first graph the h of x. What's my y-intercept? What's the there? It's 0, right? Because there's no plus or minus anything at the end.
And 2 is slope.
And my slope is up 2 over 1. Very good. So graph this one. Now let's graph our parent function again. So we start at 0, and what's my slope?
2 over.
No, parent function, the green one. Yep, up 1 over 1.
Yeah.
And then graph the line. So what do you notice about these two?
parallel.
They are not parallel.
They're intersect
They intersect at
at
0, 0. Very good. At 0, 0. They have the same y-intercept at the origin. So I'm just going to go over this summary. You do not have to put it in your books, but I do want to go over it. Okay, so when you're comparing graphs, which we just did, changing the slope, which is represented by m, or b, which is the y-intercept, creates families of linear functions whose graphs are related to the origin, the parent function. So like the first one is very similar to what we did. This would be considered parallel because they have the same slope. Okay, these have different slopes, but they all have the same y-intercept. This one over here has different slopes because some of them are negative, but they all have the same y-intercept. Okay? This is just something for you to keep in mind when you're graphing. All right, does anybody have any questions about this lesson? That's pretty much it. So I'm going to call it 3 through 33 odd. Make sure you show your work. And I believe you're doing some graphing. Let me check. Evaluate. Yep, you're doing some graphing, so you will need a page or 2 of those graphs.